So this is one of our solution calorimeters, and I wanted to give you a little bit of an introduction to it so that you know what the parts were and sort of how it works before you come to lab. So this end of the instrument is where the calorimeter is. This is just the control box. This part here is all the stuff that goes into the calorimeter. So inside the calorimeter is a stir bar, an equilibration tube, a heating element, and a thermistor, or a thermometer, a temperature sensor. This all goes inside an insulated container, this little glass dewar that's inside there. This is very fragile. It's a vacuum dewar, so there's thin glass walls with vacuum in between, but it's well insulated. So that's what we do our experiment in. All of those parts have to go inside that little glass dewar, so you have to be careful when you put this in. And the stirrer is powered. It uses this belt, which we connect to this little gear in the back here, like that. So now we have the calorimeter set up to run. One of the things you have to do once you get it set up is start the stirrer. So that's controlled by the control box over here. The instructions are on the calorimeter, but just to make sure you will understand what it means, it says star 101, stir, 1 equals on, 2 equals off. Well, this uses old-fashioned commands, so you have to do this. You do star 101, enter. That tells that you're going to enter a star command. Then you hit the number 1 and enter to turn it on. When you want to turn it off, you just do star 101, enter again, hit 2 and enter, and it'll stop stirring. And there's a similar command to send data to the computer. We're not going to do that right now because we're not going to collect any data. So let me tell you a little bit about the other stuff here. This little box is a timer which simply tells you how long the heater is on. So right, we talked, there's a little heater in there. We use that to put a known amount of power in so that we can calibrate the calorimeter. The control box for the heater is this. We usually leave it at 12 volts, and we have an on and off switch and another switch which switches between measuring the voltage across the heating element and the voltage across a small calibrated 1% calibrated 10 ohm resistor. If we know the voltage across that high precision resistor, we can calculate the current. And if we know the voltage across the heating element and we know the current, we can figure out how much power the heating element is dumping into the calorimeter. You'll measure those two voltages on the voltmeter hooked up to this control box. The only other thing I wanted to show you was using the equilibration tube to do injections. So to do that, I'm going to take this out and put it in a beaker so you can see what's going on. And maybe zoom in on it a little bit to make it even easier to see what's going on. So I'm going to step out a second and zoom in on this. Okay. So what we're going to do is put 8 milliliters at a time into the equilibration tube, and then it ends up sitting in the calorimeter until the temperature is equilibrated. So I'm off screen here filling a volumetric pipette with 8 milliliters of water. Okay, so I have my water sample, And what happens is the water sample, or whatever you're injecting, is going to go into the equilibration tube. Remember, for volumetric pipettes, you don't squeeze them out. You just let it run out as much as comes out with it touching the walls. And it stays in as part of the calibration. So then that's going to sit in the calorimeter for a minute or two to equilibrate. We'll put this cap on so that nothing gets in there. That cap has this little glass tube, and in the glass tube there's some glass wool that also prevents any debris from the rubber squeeze bulb getting in. So once it's equilibrated, you're going to use the squeeze bulb to gently inject the liquid. When you get to near the end, what you'll find is that the squeezing gets easier. You've got to make sure also not to suck back. So you squeeze gently, and I don't know if you can see the liquid stream going out, but that would be going into your calorimeter. You just squeeze slowly and gently. And get most of the liquid out that way. So that is the introduction to the calorimeter, the solution calorimeter.